In this lecture, we will discuss about group homomorphism. So we start with group homomorphism. Group homomorphism. So earlier we have discussed about the coset, normal subgroup, subset, subgroup, etc. So here we start with the group homomorphism. So this is our chapter. Now we take the first topic as homomorphism. So what is homomorphism and how to define this homomorphism? So for defining the homomorphism, we write down as let G and G dash be two groups. That means both are satisfy the property of closure, associative, existence of identity, and inverse. And function f, we have a function or mapping from G to G dash such that function of AB, f of AB is equal to f of A into f of B for every A and B belongs to G. So A and B both are belongs to G. So then F is called homomorphism. F is called homomorphism G into G dash. और शॉर्ट में हम इसे कैसे लिखते हैं? We can write down in short G is homomorphism to G. That means symbolically we can represent F is called homomorphism G into G dash. Now we extend this definition as if F is homomorphism, F is homomorphism G onto G dash, G onto G dash. So then G dash is called homomorphic image of G, homomorphic image of G, image of G. So before we start the examples, we understand about the function. So we know about the function. That means for defining the function, we have two sets, x and y. So x and y, so this is the domain, here is the codomain. So a mapping f from x to y. So a mapping of function we take as from x to y. So that means the element of x we denote it as small x, or element of y we denote it as small y. So a small y. So that means we define the function y is equal to f x. So y, we can say that y belongs to y and x belongs to x. So x is the element of domain. So this is known as the domain. This is known as the codomain. And the element which are related to x in set y is called the range. Or range is always subset of codomain. The range is always subset of codomain. So this is the definition of function. So we can say that y is equal to function of x. That means all the element of set A related to the unique element of set B. So we have one element in set A, that is x. A means set x, which is related to unique element of set. So basically we take the definition as A and B. So A and B both are the element of G, means domain element. And FA and FB obviously belongs to the codomain, that we can denote it as Y1 or Y2. Now, for solving problems related to homomorphism, we take examples to understand easily. So first example, we start with this. Let G, group G, which is defined as set of real number under addition. So G be the group of real numbers under addition. Addition be the operation, and another group that is G dash. G dash is the group set of positive real numbers under multiplication. So B two groups. तो दो different group हमने define किए. That means R under addition or G dash positive real numbers under multiplication. So B two groups, and function is defined as from R to R plus. That means real number to positive real numbers. So by setting, we take as function of x, f of x is equal to e raised to the power x. So function is defined as f of x equal to e raised to the power x for every x belongs to R, means domain, this R. So then prove that f is homomorphism g on to g dash. So आपको ध्यान रखना है, अभी यहाँ पे क्या है, हम g on to g dash. So when we are going to prove g on to g dash, so it is necessary to prove function is homomorphism and function is on to. So that means homomorphism FAB, and on to take the element of set B, and we say that this element have the pre-image in set A. So for solving the example, the solution of this, the first we prove that f is homomorphism. So f is simple homomorphism, so we can say that f is homomorphism g into g dash. So here we are going to prove f is homomorphism. So we know that the definition of homomorphism definition is function is defined from g to g dash, so such that fab is equal to fa into fb. If this satisfy, so then we can say that f is homomorphism g into g dash. So f is homomorphism g into g dash. Yeah. So g into g dash. Now, so we take the element of this G. So basically, the group G element, that means a set of real number of operation is under addition. So we focus on this operation. So we can take two elements. So let G has two elements. So you directly can write down. So let A and B belongs to G. G means first group. Function is defined from R to R positive. So that means basically you can write down as function is defined from G to G dash. What is G here? G is real number under addition, and G dash is positive real number under multiplication. So basically we can start by using positive real numbers or real numbers. So we can directly take as G and G dash. So A and B which belongs to G. So then when A and B belongs to G, so by definition of homomorphism, we can write down as A plus B. जनरल डेफिनेशन में क्या है? जनरल डेफिनेशन में हमने लिखा है एफ ए इंटू बी. अगर कोई भी साइन नहीं ले रहे हैं, दैट मीन्स अंडरस्टूड है, दैट इज द अंडर मल्टीप्लिकेटिव. एफ ए इंटू बी इक्वल टू एफ ए इंटू एफ बी. बट यहाँ पर हमें क्या है कि यहाँ पर जो जी ग्रुप जी डिफाइन है वो पॉजिटिव रियल नंबर्स, दैट मीन रियल नंबर्स के लिए डिफाइन है, और अंडर ऑपरेशन है हमारा एडिशन. तो एडिशन है और ए और बी किसके एलिमेंट है? ग्रुप जी के एलिमेंट है. तो उनके बिटवीन में जो ऑपरेशन आएगा वो क्या आएगा? फिर प्लस आएगा. सो दिस एफ ए प्लस बी इज इक्वल टू, अब एज पर डेफिनेशन ऑफ फंक्शन, तो फंक्शन इज डिफाइंड एज इन दिस फॉर्म, तो फंक्शन ऑफ एक्स इक्वल टू ई रेज टू द पावर एक्स. अब यहाँ पर एक्स के प्लेस पर हमने क्या लिखा है? ए प्लस बी. जब इस फंक्शन में हम पुट करेंगे वैल्यू को, ए प्लस बी को, तो ये क्या हो जाएगा? फिर ये हो जाएगा ई रेज टू द पावर ए प्लस बी. इसका मतलब क्या हुआ? हमने एक्स रिप्लेस कर दिया किससे? ए प्लस बी से. सो एफ when replaced by a plus b, that means x. So अब आगे क्या होगा, दिस कैन बी रिटन एज e raised to the power a into e raised to the power b. So we have the property that means when we write down separately, so this can be written as e raised to power a into e raised to the power b. Now we using this definition of function, that means, so what is the definition? E raised to the power x can be written as fx. So e raised to the power a, this can be written as fa into e raised to the power b can be written as fb. सो दिस एफ ए प्लस बी कैन बी रिटन एज एफ ए इंटू एफ बी. अब ये देखिए आप कि जो जी डैश है, जी डैश किस में दिखाया डिफाइंड है कि पॉजिटिव रियल नंबर अंडर मल्टीप्लीकेशन. तो यहाँ पर जो ऑपरेशन आ गया वो मल्टीप्लीकेशन आ गया, और वो जो एलिमेंट्स थे हमारे ए और बी, उनके बीच में क्या ऑपरेशन था, एडिशन. बिकॉज जो ग्रुप जी, दैट मीन फर्स्ट ग्रुप जो डिफाइन था वो अंडर एडिशन था. सो देन वी कैन से दैट function is homomorphism. So f is homomorphism. So f is homomorphism. Now, after proving f is homomorphism, so we can say that f is homomorphism g into g dash. Now, second thing we will prove that f is onto, because this can we prove that g is homomorphism, that f is homomorphism g onto g dash. So we prove that f is onto. So second thing we will prove that f is onto. और ऑन टू फंक्शन के लिए कैसे करते हैं, तो फॉर प्रूविंग ऑन टू फंक्शन वी टेक द एलिमेंट ऑफ g dash and we shall prove that that element have the pre-image in g. So we consider as let y be the element of पॉजिटिव रियल नंबर्स. तो पॉजिटिव रियल नंबर कहाँ डिफाइंड है हमारे जी डैश में. तो y be the element of positive real number, so then there exists an element, there exists an element, which element belongs to R. So there exists an element log y. So log y definitely belongs to the R. So how to say that log y belongs to the R? Because the function हमें क्या डिफाइन है कि फंक्शन डिफाइन है एफ एक्स इज इक्वल टू ई रेज टू द पावर एक्स. अब एफ एक्स को हम क्या लिख सकते हैं, वाई लिख सकते हैं. तो वाई इक्वल टू ई रेज टू द पावर एक्स. अब जो वाई एलिमेंट है आपका, जैसे ये है, ये वाई एलिमेंट हमारा किसका हो गया, आर प्लस का हो गया. अब हमें ये शो करना है कि जो एक्स एलिमेंट होगा वो आर में होना चाहिए. मैपिंग हमारी क्या डिफाइंड है कि फंक्शन डिफाइंड है आर टू आर प्लस. अब ये हमने लिया कि y जो एलिमेंट लिया हमने y आर प्लस का लेके चला, तो फंक्शन एफ ऑफ एक्स इक्वल टू वाई लिख दिया, और द इरेज टू द पावर x. तो यहाँ से x की जब वैल्यू कैलकुलेट करेंगे तो टेकिंग log बोथ साइड, तो log y इक्वल टू x. तो इस x जो होगा हमारा वो क्या होगा, यहाँ पे log y होगा. तो log y दैट मीन x इक्वल टू log y, सो बेसिकली बिलोंग्स टू द r. तो ये जो log y होगा वो किसको बिलोंग करेगा, r को बिलोंग करेगा. सच दैट अब जब आर को बिलोंग करेगा तो हम उस फंक्शन में जब पुट करेंगे वैल्यू को, तो फंक्शन में पुट करने के बाद क्या वैल्यू आएगी हमारी कि एफ ऑफ एक्स. अब एक्स हमारा क्या है, लॉग वाई है. तो एफ ऑफ एक्स हो गया हमारा लॉग वाई. लॉग वाई इक्वल टू ई रेज टू द पावर एक्स. ई रेज टू द पावर एक्स क्या हो जाएगा, लॉग वाई. और लॉग वाई और when e base of log that have the value 1. So this means this equal to y. So f of log y equal to y. So f of log y equal to y. So that means it is clear that y is onto function, because the image of the function going to y, or we can say that y belongs to r plus. So f of log y equal to y. So hence f is onto. So hence we can say that f is onto. So that means function having pre-image and images. So f is onto. So we can say that the set of real number under addition is homomorphism g into g dash. So positive real number 2 into